Hello, everyone, and welcome to Handmade Hero, show where we code a complete game live on stream. There is not much to say today. We made a thing for ourselves last 2 weekends. I guess not last weekend, because last weekend was a very special episode starring John Blow. This week is not starring anybody. But if you remember correctly, we added a little drawing thing, and our drawing thing tells us a bunch of information about the collision stuff, which honestly kind of works pretty good. We have not really had any problems with things getting stuck. And so our goal of the collision system not producing sort of bad outcomes seems to have worked pretty well, although obviously we haven't stress tested it much. However, we did want to do some stuff. So, like, for example, this sort of thing where, when something hits another piece of geometry, it doesn't get stuck. Like, I can still move it just fine. But it doesn't really have, like, roll. You know what I mean? So things can still, well, that doesn't really do it. But, like I just did that, where something is trying to move straight, and so the target of the thing that it's moving towards is straight ahead, but there's something in its way. We don't really have a good answer right now for how to make sure that that they smoothly kind of roll around, which is what we would like. And what you can see here is we started drawing some things like these here are vectors, sphere collision vectors from the place where the thing the sphere is colliding with, and the center of the sphere. So you can see it was testing sphere positions in a couple different places where, it felt like it could go, and you can see it testing them here. And, I do wonder a little bit, based on looking at it, it actually looks fairly clean. So I'm not really sure. We could add some more drawing since we have drawing now, but, the drawing sort of suggests to me almost that maybe the code is actually just correct and there isn't much need to fix it. And so my thinking is what we may actually want to do to fix this particular problem, it may have nothing to do with the collision detector. It may simply be that we don't search far enough around, right? So when we look here, we only search the voxels immediately neighboring to the voxel that we were picking. And you can see that because the voxels themselves are kind of aligned with the geometry fairly well, which is, maybe not a good idea. Like, maybe we should stagger those. But no matter what we do, you can always imagine a piece of geometry getting aligned fairly closely to the voxels, because the geometry moves around, and we don't have any real restrictions in this game about where geometry could be. We have a grid that we put in areas for gameplay reasons, but that grid doesn't have to be there, right? Like, we could easily make a level where things were smoothly moving around, and maybe we'll want to do that someday, and our engine does support it. So we really don't want to force any sort of, we don't want to solve problems just by using alignment. So when you look at what's happening here, I'm wondering if our main problem is just that we need to search a little bit further. So we need to go, if we don't find a way to accept a movement in the local space, we need to try at least one more square than we were trying. You know what I'm saying? So I wonder if that's the main problem that we're having, is we don't really have any way to fix that problem. And I really, like I said, I don't know. So I'm not suggesting that this is the actual solution. I'm just saying I wonder if we fundamentally can't solve the problem the way it exists at the moment, and if we... Okay. Why did that not work? I never know why this doesn't work. We never really got the for-coder flurry thing sort of really working. At some point, I'm going to have to do more of that. But, we have a build thing here, but it doesn't seem to actually build I think because I don't remember why. But like it didn't seem to actually work. Like you do this and then you say like build and like it just doesn't build, but I don't know why. Because I mean there is a build.bat, right, in that directory. It's right there. If I do it from the code directory, it works. So if I'm in that directory, and that did load the project file, I have no idea. Is there a project file in here? No, I don't know. Oops, that's a dir. Yeah. I don't know. Hey, it sort of works. I guess that's good. So anyway, if we take a look at the code for that, which is in move entity, the thing that I'm basically talking about is what we test. So you can see our voxel iterator thing here, which basically goes and says, let's try these voxel locations, and you can see it taking steps. So yeah, like my thinking is just that if we change a little bit about how we test these voxels, that might be sufficient. Like you can see how this works, right? So we do a for I loop, you know, and we go through here and we say each time in the loop we're going to test nearby voxels to see what happens to them, and then we're going to select the best move of the options that we have. And my assumption is just that, like, yeah, if we just change a little bit how that is lined up, that's really all we need. So you can see, like, the min corner here, right? We start with one of those, and we just move through the min corner like so. And so it would seem that if we broaden that a little bit, that might be all we would need. So this also, like, this seems cited as well. Like, if you think about it, yeah, like it's literally just testing just that one voxel. And when it tests it, like, it can only move, like, it won't try to move anywhere where a side isn't open, right? So one of the problems is this drawing kind of doesn't really help, right? Because I can't see, even though, like, we assume we know, because we would be like, well, okay, like, this side is probably open, right? Yeah, so okay, so let me say it this way. I do think it's correct to only check voxels whose exit criteria is what we think it should be, right? So we shouldn't be checking voxels like where, like, we're in an outside voxel and then we, like, go into an inside voxel. Like, we should not be doing that check, right? But the problem that we're going to have here, as you can see, is we do a check, and we only accept the voxels that contain the new closest point. And so each time through our system, when we hit a voxel that is closer, which can contain a point closer to the target than the voxel we're in, we always take that move. But if that move actually won't end up producing the closest point to the target out of the voxels nearby because you had to go through another voxel first, we'll never find it, right? So that's mostly the problem, I want to say. I don't have really any other ideas about what's going on there. We probably should draw lines between these. So like in this thing where we do these diagrams here, right? So that's what's drawing like this stuff. It would be nice if we could see which order these got done in, right? Or like, like it started in one and it moved to another, right? And we can't really see that at the immediate moment. We just get color coded boxes, but they don't really tell us very much information, right? I'd have to go look up what those colors even mean, but I believe the yellows are ones that had some in, some out. And so we probably went from like here to here looking for places or something like that. And we didn't find one. So like when it came to here, it was like there isn't anything closer or, something like that. So I'm not really sure, which is why I think we need to draw more stuff. I believe red boxes are ones that that we can't go into, but I don't know. So let's take a look and just see what that drawing actually does. So that would be where? Here? No, for fine voxel placement. So I assume it's this, and I assume it's these. So it starts off green. If it's not occupied, it turns yellow. I'm sorry, it starts off red, so that's occupied. If it's not occupied, it turns yellow, and if it ends up being one that it actually accepts as a move, it turns green. So I guess that does tell us mostly what we need to know from this because it's such a simple set of boxes. There are so few. Like looking at it, it is basically what I said, assuming there aren't any bugs here with producing those ideas. It looks like what happened is we started in the interior cell. So we started like in here, right? We tested this cell, and this cell. And what we found was that this one and this one both could have contained the point, meaning there were points on these voxels that were non-colliding. So it is legal to place the glove in these two squares, but there was, like, neither of them contained a point that was closer to the target point, which is this wobbly little fellow out here, right? That's just randomly, frame rate dependently, and quite buggily, actually, but doesn't matter because that's just that controller code can be as buggy as it wants. At the moment, the collision detection should not matter, right? And that's a very important thing. We don't want the collision code to fail when something is buggy. We just want it to work, no matter how bad, how sloppy the gameplay code, whatever it throws in there. If it's wobbly or stupid or shouldn't be where it is or whatever, anything else, that should still work to the best of its ability. That's what we want. And so you can see what happens here. We would probably like to put it in this cell, right? This diagonal cell that would be right here. That's where we would like to put the glove. But we never test that cell, and the reason we never test that cell is at the moment, I don't know that we are ever trying. And so it may be the case that we just need to update these to handle diagonal motion, and maybe that's enough. So diagonal across an edge, right? And I want to say that, like, that was a question. Somebody asked, like, why don't you do that yet? And I just said, because we haven't gotten there, right? So it's not like we said we shouldn't do that. We just didn't. It looks like in this particular case that would solve the problem. Whether that means that that's a complete solution to this problem, I'm not really sure, right? Oh, in fact, here you go. Here's a comment, right, that we actually put in there. And I think that was based on a question somebody asked. And the answer is I don't have a reason for not doing it. I also don't have a reason for doing it. It's literally just because I haven't thought it through yet. And I don't think there's any reason why you couldn't allow that. the only problem that I see is that I don't know if this is a sufficient solution, right? Like, it may be that the better solution is to look 2 cells away always, right? Which would include those cells that would be captured by this diagonal motion, but it would also include other cells that are further away and be more permissive in the motion of the object as far as getting around obstacles. So that's really the thing I'm not entirely sure about. And so I really don't know. I will start by just trying that and seeing, because I guess we don't want our collision detection to search harder than it needs to. So because I can't really come up with any real mental rubric for deciding this theoretically, I guess I'd just say we solve it practically and go, let's try putting those 2 cases in. Because it's only 2, right? It's motion through the corner and motion through through the edge. Although actually, motion through the corner, I guess, is handled here. Maybe? Because this is the corner. Let's take a look. So motion, I'm a little confused because it seems like motion through the corner actually should be handled. I wonder, do we not set this? So what are those like dir inside things set to? Because I don't remember what we set them to. So, like, direction is definitely set to go through the corner, whichever corner you're going to move through, right? And same here. So, like, if it's less than 0, then it stays on the side. Otherwise, it's 1. So if you had all positives. So I guess... So I guess what I would say is, actually, this doesn't quite seem right, does it? A lot of this seems a little wrong. No, I guess, okay, I can be comfortable with that. So, yeah, like, this will check the corner, right? It will check whatever corner you were going to leave through, won't it? And so what I'm a little confused about is why we don't see a corner test being drawn. Looking up here, so when we begin this diagram, right, and we start drawing, you can see here that we set a color to black, and we claim that we draw a best cell, and then we set a color to white, and we claim that we draw a smaller box, right, at this position. And it sure doesn't seem like that's getting drawn, which makes me wonder, like, is it because this filtering system is buggy? Like, I mean, we only just made it last time we coded. Is there a bug in it? Because why am I not seeing any of this? Like, where's the black box that says where the best cell was, right? At the start, if that's the initial position, right? And so if I look at this, it's like, I don't know, I'm not seeing that, right? I definitely don't see that. That white square there looks like it might be. So the white square is where we're starting out, and that does look correct. Although it's got a little like cyan plus in it, which makes me wonder, like, that probably isn't this code though, right? Like, here's an easy way to test. Right? No, that was it. So I don't know, like it looks like for some reason that the black box best cell just doesn't draw, right? It's just not there. Because the white box is drawing. So is best cell like a garbage value or something? Like, what's going on there? Do we have a bug in our color routines where they don't, 000 color doesn't properly extend the alpha value or something? Like, what is happening? Am I the only person who thinks that's weird? So here's one other thing I'll do just real quick. If I nerf the entire routine, so let's suppose it's just gone. Like, we don't do anything else. So it doesn't happen, right? So the only thing we draw is the white box and the black box. That's it. Do I see them? Are they getting, like, overdrawn with some other thing, right? That's, I guess, what I'm asking. So that black box never gets drawn. The white box does get drawn, and we have no idea why. So let's test a couple things because we need the diagramming system to be reliable if we're going to do anything with it. So the first thing I'm going to do is I'm going to change the color from black to red to see if there's anything weird about the fact that, like, the color was black. I mean, I don't know. There shouldn't be, because I don't see why. Like, it's just passed through. It shouldn't matter. And it doesn't appear to. So now let's leave the color black, and I'm going to copy the construction that's used here so that we can just say, well, okay, so suppose that best cell, we just forget about what best cell is entirely. And I just draw a bigger box on top of the box that we already have. So we kind of know where it will be. It's just a slightly larger box. Do I see that, right? And I don't. So now the next test I'm going to do is I'm just going to reverse the order of these two things to see if it's that the first thing I draw with the diagram system doesn't work. Because then that would give us a clear indication of what's going on. So here we go. And that is apparently the case. Like, you can see that you can see it right there, right? There's the black box now. So it seems like we just have a problem where the first thing that whatever we say on the diagram, when we first push, like, the box on there or whatever, that, like, doesn't get drawn for some reason. And so we should be able to see that pretty easily. I'll take a quick look at inspecting it, but, assuming that I can't immediately see what the problem is, we should be able to step into the debugger really easily and verify, A, does it get pushed, and B, if it does get pushed, why doesn't it get drawn when we actually loop over it, right? Like, what happens in here, we have, like, this, we have, like, these attributes, right, where we set the color, we set the thickness, and we kind of have these current and sticky things, so you can kind of, like, set permanent color, whatever, nonsense like that. And you can see what happens here is we have a current equals sticky at the end of each of these. And you can kind of see, like, we set, like, when you do color, we set, like, the current color to be things and the current thickness and all that nonsense, right? So there are a lot of ways you could imagine this thing failing. In here, there's a couple things we don't do. So when you hit a diagram begin and end, we probably wanted to keep a little stack that says, let's restore what the color was inside of the diagram. So this part probably wants to get fixed, and it could be that something that is happening before here is affecting it. The reason I don't think that's the case is because diagram filter should be preventing any of those things from actually ever getting pushed, right? Because if you look at what happens in here, everybody's predicated on if entry. And so I don't know that anything would ever be on the stack in that case, right? So it's probably not that. If you look at how PushCube is working, right, it just does exactly what you would expect. It uses the color. Like there's really nothing weird about that. It uses the thickness as the radius, the white texture for the fill. And you can see that this is a bit suspicious. That part there, I guess. And the only reason I say it's a bit suspicious is because what happens the first time you draw something is you set current equal to sticky, right? And so if you've never drawn anything, that line hasn't happened. Now, I don't think that line should have to happen because this should have already done that. Like, this piece of code right here should have already set current equal to sticky. So this should be initialized to valid values when we enter this loop for the first time. It should encounter a color line, which is current.color equals entry.color. And I can't see, like, because that does push a 1 on. Yeah, I don't know. So I don't see it by inspection. I'm thinking I'm just going to have to... I'm going to have to step through this because I don't really see why it would be failing to draw that. I mean, I guess I can double check the box routine, but, there's nothing really much going on here. It's pretty simple. There's really nothing interesting is happening there, right? And the diagram group... I don't suppose there's a place you can over push this. Is this code wrong? Like, so when it does its linkage, is this wrong? It looks fine to me. So, I don't see a lot of issues there either. So, I don't know. I don't see anything wrong with this, so we're going to have to step through, and we'll see what we see, I don't know. I'm hoping it'll just jump out at me as something stupid when we step through it, but if it doesn't, then I guess we're just going to have to put our thinking caps on and figure out what the heck is wrong here. So the first thing I'm going to do is I'm just going to try to check to see if this thing gets pushed on properly. It should be the first thing that's pushed on that passes this, right? So the first time we push something on, we should hit this case, and that case should, it pass the filter, and we should get an entry that is whatever the entry is, right? This is the new entry, and we're going to stick crap in it. So there's the instruction, which is the thickness instruction. We can go see who's doing that, because I don't know. And, okay, so there's a diagram text call that's happening here. That could have something to do with it. Like, maybe that code is buggy. So here's diagram text. Okay. Yep. That's our bug right there. So we go to push on one of these entries, and it's called a diagram thick, but it was actually diagram text. That's probably it. Yep. If only we had a language that supported discriminated unions, you wouldn't be able to have that bug. To be fair, it's not a bug you have very often, and it doesn't take very long to fix, as you saw, but still, it's not a bug that you really should ever have. Does JAI support discriminated unions? I don't know. John and I's programs don't tend to look similar, so I never really know if he would care about a particular thing that I would probably care about a lot, right? So yeah. Anyway, so yeah, like you can see what was happening there is this was just pushing on the totally wrong thing. And of course, the way that we wrote this code, it's almost impossible for it to actually ever crash because of that. If you pushed on something that wasn't a diagram text as a diagram text, because that does involve a pointer, that's the one place you would see it. But pretty much anything else you do will just work. It just won't work correctly, right? It's sort of like a JavaScript program in that sense, is that the bugs are all still there. They just don't crash the code, which is somehow seen as a victory. Anyway, so in this particular case, I think that's probably all it was. So now we should get that little black square there, right? So let's see. Perfect. Okay, so going back to move entity now, we shouldn't have to nerf this routine anymore. We should be able to see everything we expect to see, like so. And looking at this code now and, you know, just looking at wherever the thing is, yeah, so that one is actually, okay, so that was crucial because now I can see that it actually is testing the diagonal, right? So it's not testing that one right there is the only one it doesn't test, right? Oh, well, actually those two too. Like there's 3 edges that it doesn't test, right? So the diagram verifies that things are happening, so that's good. Let's go ahead and try adding those side motions, I guess. So if we take a look at this code here, what this would be is you could see these testing flat faces, right, for movement. And so a face, because it has, in this case, 4 corners, they get tested to see if they're all open. It's not clear to me that that's actually correct. Because, you know, maybe we should say that only 3 have to be. I don't know. But, in fact, let me go ahead and put that in here. I don't know if that's, you know, better or worse. I really couldn't tell you. What you can see here is that if I go ahead and produce an edge motion one, then what we're going to see instead is rather than checking for 4, which is what a face is, we're just going to check for 3, which is what an edge is. And it would be the combination of any of the directions. So we would have something that looked like, a dir x, dir y, you know what I'm saying? A dir x, dir z, and then a dir y, dir z would be, which sounds like a German word, like, we the like it sounds like the dir y, dir z sounds like a river in Germany. So once we have, these update direction checks, we need the occupied flags. Now we're really sounding like a river in Germany. We need the occupied flags to be tested for those edges. Ah, boy. Okay. So if we want to do dir y, dir z, then what we're looking at here is, in terms of these, if whichever motion we're not doing is the one that we need both edges on, I believe, right? So we're going in the dir y, dir z direction, but we have to check that edge. So I think the way this would work is like the 0 and 1 code goes with whichever one this is, right? And then these are both going to be just whatever their actual side is in this case, right? So we're looking on the side that we're going, and then we're just saying like the vertical edge in that direction, right? And that's how we would move through that side. And so the same would go here. So this would be like, the same thing, but where the edge is along Y. So that's, moving the upward way. And then finally this one here, which is along X, right? And I think that's what those are. Wait a second, I have to check the stream. Is somebody seriously talking about Rust again on the stream? You know what happens when someone talks about Rust in the chat. You know what happens. Why would you do it? Why would you do it? Who is responsible for this? Why is Rust getting discussed in the chat? The executions will continue until morale improves. Yes. It gets the hose again. It gets the hose again. All right. I'm going to look back at my program now. And the next time I glance at chat, I better not see the R word on there. All right. Maybe if you want to, you can just do R star 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 or something, right? Like if you write out Rust with a hard ST at the end, that's just like you're instantly canceled from the stream. All right, so let's take a look at what this works out to be. I'm just curious. The goal here is to have it check like the entire block, right? And you can see that now we have like a full cube of testing going on there. The full cube of testing. And I'm just curious if that changes what we see when we look at the corner cases now. And, just take a look here. Okay. So okay, so you can kind of also see this actually illuminates this much more clearly now that we can see what we're actually doing here. I'm going to go out on a limb. I don't know. I'm going to go on a limb and say that we now have a slightly different bug. The bug that we have is that this won't work, but the other side will. That's just a totally random guess on my part. I have no idea, but I'm just going to say maybe that's what happens. Ooh, almost, but not quite. So we're still in that place where no, even, and I guess I don't know why that is. That's really weird. So it switched which direction it was testing, depending on which glove side it was? How did it do that? It seems like we have something that uniquely picks the wrong side to test, which I don't know how I did that. Can we instead change our code to uniquely pick? I was assuming that since it picked that way on this side, it would also pick that way on this side since they're both trying to go forwards, but that's apparently not the case. I also am not sure why that doesn't work. It looks like that would have enough clearance, but I guess the glove is a little bit too large. So yeah, to me, it looks like, I don't know, that doesn't look like it's wrong. It still looks correct. So my assumption is it's not going to work by just testing the local neighborhood. Like, if you want to actually have roll-off, you're going to have to test, like, a larger neighborhood, right? That seems like possibly right. Like, yeah, you know? So that's my guess. I'm not sure. But we'll see. So I think, I think that's the entirety of it. So how do I want to do that, though, is the real question. And I'm not sure about that. So I'm not sure how I want to test the one neighborhood, or I guess I should say the two neighborhood in this case, because it's sort of the initial point. But you can see what I'm saying here. So basically, we end up in this situation. The actual closest point is probably in this square right here, but we're never going to test that square from this square. You know what I mean? So I really just don't know. So we're going to have to think about this. Obviously, it's trivial for us to just check more of these cubes because it's just a function call. So we can construct the code that checks as many cubes as we want. It's not like it's hard to construct the algorithm to do that. The question is, how do you construct an algorithm that intelligently tests only the cubes that it needs to and doesn't just test like tons of cubes unnecessarily, randomly looking for the place to put the point? And so I feel like that's sort of more the issue there. I suppose, By the way, no, you're only not allowed to say the R star 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 word. RPG Maker is fine. So is Game Maker. Unity and Unreal are also fine. Just not R star star star. I do have some serious reservations about Unity now, so I don't know that I would necessarily recommend anyone use it instead of one of the alternatives like Unreal Engine or Game Maker or something. But, like, you know, if someone does want to use it, I mean, okay, you know, that's their choice. I don't think there's anything, like, super wrong about it or something. It's just, it seems like I don't think it's got a lot of longevity as a game engine these days. I mean, just based on what, you know, if you listen to their corporate conference calls and you just see like basically what the track record is of the program, I mean, I don't think it's a sane thing to build a company or a project around anymore, right? So I would strongly advise against using it, but, you know, if for some reason you really think it's a good idea, it's not like R star 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 where I'm just like, I really don't like the people and I don't like how they constantly antagonize people about it, so I just don't like it on principle, which is not true of Unity. Nobody from Unity has ever antagonized me about anything, right? So I have no reason to suspect that the people who work on Unity are like bad or something, right? So anyway, if we take a look at this sort of part of the algorithm here. By the way, I don't really remember why these things are getting highlighted. Is that because they're getting checked for collisions? I don't even remember, right? Like, I assume that we highlight that because it's getting checked for collision, but I don't even remember writing that piece of code. Apparently we did, which is great. I mean, hey, it's kind of a good piece of information. Not that we're really using it much, but still cool. So if we look at what's going on here, we need a strategy for like widening the search space to some squares. And what that means is like this kind of thing. And you can sort of see why this is happening too, because in general, we sort of don't really handle like a particular narrow band case. Like if you look at what's going on here, you can see that we're sort of making the arbitrary distinction that if something is positive, it goes one direction. And if it's negative, it goes the other direction. We don't really talk about what happens if it's zero. Or close to zero, right? And for numbers that are close to zero, like this one is, right? This is something that's moving directly down the y-axis, right? The glove is moving straight forward on the screen, which is directly down the y-axis. And so we arbitrarily classify that as like +1, maybe, or if like the floating point value is just a little bit off, you know, then maybe we classify it as -1. But the point is, whichever one it ends up being classified as, it was like totally arbitrary that we decided to classify it in that way. We could just as easily have classified it the other way, making this sort of like a bogus choice. Now, if the thing is like solidly positive or solidly negative, meaning we're clearly going to the left or we're clearly going to the right, or something like this, right? So in this case, right, x is the thing we're talking about. X is basically 0 for this motion. And so we're arbitrarily classifying it as saying only search to the left or only search to the right for this thing. And that's kind of wrong. So we have that problem. And then the other problem is apparently even that's not quite enough. In other words, making that distinction correctly may not be enough. It might fix that case, but it wouldn't fix that case. Did I get it right? Let me see. Yeah. So you can see in this case, well, no. I thought we had one where we were checking the right direction. Maybe we don't. Maybe it would fix these cases. Is that it yet? Oh, well. I can't quite tell if that case is happening. let me... I guess we somehow never get that case. Somehow, no matter which side we're on, we always pick the incorrect thing, which is impressive. I'm not sure how we did that, but apparently we did, right? I don't know. I don't know how we did that. Doesn't seem like that should have been possible. So I guess I don't really know. Maybe if it did pick this, it would work. Hmm. So I'm thinking of a couple things here, and let me just say them out loud. So one thing that occurs to me is that if we look at one of these squares, what we could do is, yeah, and you know what? Now I'm thinking about this. This makes a lot more sense. So it seems to me like this maybe is the wrong way to look at the problem. What this does is it says, let's classify the kind of motion that we're about to do statically for the actual movement between the place that we're starting and the place that we're ending. And we use that as our voxel direction the entire time. But it occurs to me that probably what we really should be doing is classifying which direction we would want to move or check dynamically as we march through the voxel. Probably, right? And I don't know, like, we obviously need a thing that prevents us from revisiting voxels we already visited, though, because otherwise, unless we can come up with a perfect scheme which never produces the same voxels twice. And that, just to be clear, that's why this is a slightly harder problem, because as we currently have it, because we're always searching along a single direction, we can never visit the same voxel twice, because we can only move forward. We can never, like, we can only move in these directions that we've picked once. We can only go in this direction. So if we pick -1 for an x step, we can never move +1 in an x step, right? So it prevents us from ever getting back to somewhere that we already were. And that's really the thing that currently keeps the algorithm from revisiting existing cells, like cells that it already tried. And we don't want to do that for two reasons. One is we waste processing power on this algorithm if it's testing voxels it already tested, because it's going to produce, a predictable result. We already tested that voxel. We know what the outcome should be. And so what we really want to do here is, and the second reason, which is more important, is it would get an infinite loop potentially. Like if you had two voxels that could go back and forth between each other, we would have to start introducing something like a timeout period. So we just like, okay, after 10 tests, if you haven't found something, then quit. Because otherwise you could just ping pong back and forth between two voxels and the routine would never terminate. So right now we have the nice property of this routine will always terminate, even if it has to test 1,000 voxels to do it, to move something a really long distance, which we don't really want it to do, but it would still work, right? It doesn't produce anything buggy. And so that's a nice property of the algorithm we want to continue to have. We want the algorithm to be, don't actually test this thing this voxel if you've already tested it. And having a way to produce that automatically is nice because it means we don't have to track anything. We don't have to have a stack. We don't have to have comparisons to see whether we've already tracked something, all that stuff. And so as we move away from that and we want to test a wider neighborhood of voxels, the problem that I'm having in my head is like, okay, so what do I want to do there? Do I keep a stack of voxels? And do I say, like, okay, we check to see if we've already tested them, or do I try to have a flood filling rule that somehow makes sure that we wouldn't ever push voxels on that we shouldn't? And TK Dev, a line drawing algorithm is what we already have. And what we need is something that's more than that, right? We need something that actually is more like a flood fill, you know? And so we need a way to sort of check a wider swath of things. Now, maybe we could still use a line drawing algorithm, which is sort of what we've got right now, right? We're basically, this is basically a Bresenham's line drawing algorithm for the most part, is what we're basically doing, right? And maybe one thing we could consider is a wider line, right? So maybe we still draw a line, but we test, 2 voxels in either direction, or something like this. So, that could work. I just don't know if that's the right answer. It's a tough decision. So one thing we could do is even that doesn't really make much sense to me. I can't think of anything that doesn't track. Maybe we just do need to track. Like, we'll need to have some way of saying, look, we already tested these points. We don't need to test them again. Because I'm trying to think of an algorithm that wouldn't require that. And I can't think of anything. Because as soon as you have the algorithm ever say, we're going to test 2 directions, right? So we're going to test x-1 and x+1 for a voxel motion. As soon as you say that can happen, then the algorithm can pretty much oscillate. You can get in a position where you ping pong back and forth. And so you would need a thing that says, I already checked a previous cell, so we don't need to check that cell again. Unless I'm just not thinking of it. It really would nice to be nice to be more clever, right? It would be nice to be more clever there. But it's not coming to me. You can see, right, like, so let's suppose that you were in this scenario here, right? And you could see just saying, look, what if we just widen this up? So, what if we basically did that and tested like a 9-way test around the voxel, and so the min corner location, we actually start off like one behind that and go forward, right? So we test, something like a wider swath, and then we pick, which ones we want to go in or whatever, right? Like, who knows? The other thing we could do is, like, in here, right, we say, instead of using these side coefficients, we just actually don't, we actually have, like, all of the possible motion directions in here, and we just use them, right? That's the obvious thing to try next, and then you immediately run into the scenario that I was talking about, which is as soon as you do that, you can move back and forth between the same two voxels. So what you need is then you would need a check that's like, did I already visit this voxel? Now, it's not that hard of a thing to check, but it adds a lot of extra complexity, right? We've got to keep a stack of those things. Unless I'm missing the way that you would avoid that. Yeah, I'm just not thinking of anything. I suppose one thing we could do is try to think about, is there a way that we can have some kind of like a additional value besides just the point that we're trying to get closest to that would allow us to navigate like, okay, we tried going in this direction and it didn't work, so we'll try going in the other direction, kind of a thing. So, yeah, like, I mean, here's just a stupid idea. Like imagine if you took this loop, right? And, you're looping through here, and you can see, like, okay, you get down to here, and you find out that you didn't, like, you went as far as you could using the direction that you thought that you should move, right? In theory, you could add another thing here that was something like, tried opposites or something. And you could do, like, okay, like, if tried opposites, then break, else try some other direction, right? So you imagine, like, in here, you would say you grab this crap, And you do something else here. So if tried opposites, or whatever, you look and see if you can change one of these deltas somehow. And you could imagine doing this for each one. So let's sketch a crappy one. So a crappy one is like, this is not what we'll actually want to do if we actually try, if this turns out to be useful. Oh wait, these are the wrong, sorry, this is dir, right? It's just dir and side, yeah. So like, that seems pretty, oop, that was bad. So that seems pretty reasonable. I don't, and that's not what we would actually want to do, because we're going to want to actually test more than that permutation. But like, that would allow us to, why is my camera not, okay, there we go. That would allow us to try more. And yeah, and there you can see, right? So if we clean that up and actually test the forward ones, I mean, maybe it would work. I don't know. But that's a way of not actually having to do yeah, of not actually having to do it. The problem is it'll still yeah, but that will over test, right? Because you're still going to overlap. It doesn't require the bounds check, but it would still overlap. And there's nothing you're really going to be able to do about that. Yeah, it's still not great. So like, let's suppose we took this stupid thing, and we just said like, okay, there's like an opposite flags stupid thing, and we basically we look at these and we say, if we think that we need to test this, so like the absolute value of one of these deltas, like if the absolute value of one of these deltas is less than like our opposite threshold or whatever, oops, which I don't know what that is, but like if it's close to being something that could in theory work, which I don't know what that is, but let's suppose it is something like that. And I guess, even thinking about that, I'm not sure that makes much sense. We should just get rid of that. Let's just say let's just do this. So if we're doing the opposite try thing, it would just like loop through all the different directions to try, like as it couldn't figure it out. This seems crappy, but so each time through, you'd just like ink this thing, and you'd have like whichever one you were on, you'd do it, right? There's probably a pattern here. We could probably just make the pattern do something. In fact, yeah. So every time, yeah, you don't even need to do that. You just do this. So you do something like, if tried opposites, if this has all of the bits set, so if it's got the 1, the 2, and the 4 bit set, then you've tried like all the opposites that you're going to try, right? Something like that. So I don't know if you want to reset this every time or not. Probably not. So you go through and you say, like, okay, if the tried opposites, if we AND with 1, that means it's like gonna loop up. So every time we want to try a new opposite, we have to flip like side X, right? Because we got to pick somebody who oscillates at the lowest frequency level. So if we already were on one of those, then we have to switch side Y, right? Like if you inked that one. And at that point, we would have to say, like, if we were already on one of these, we have to also knock the other one, right? Something like that. And so each time through here, we just say, like, we flip aside. And this code sucks, and I don't think we should probably do this. But, sometimes you just have to explore something to see what it does. So here's that crappy code doing, whatever it's doing. And I don't know if this will actually produce the correct results. Let's take a look. Yeah, so it actually does. I mean, it's not efficient, so I don't think we want to use it. But it actually does produce the correct results. And so you can see now that, it's checking in there. So I guess what's a little bit weird about that is I'm kind of surprised to learn that it can't accept any of those motions, which seems odd to me. Like, but I guess that's actually true, right? Like, it would have to move so far out here before it could figure out that it could round that corner. You know what I mean? That for whatever reason, it just can't find a closer place to place it. Which seems kind of nuts, right? Because if the current location for this thing is like in there, you would think it might be able to find a closer place, which I guess does mean maybe we want to check the sphere collision a little bit more, but yeah, I don't know. I mean, in theory, that could really be true. I mean, it could really be true that collision is there. Maybe we should draw that diagram a little bit more. Like, maybe we should try and put some clearer bounds on this. So one thing we could do is draw the sphere for the glove so we can see whether we think it should be able to be placed in there or not. Because right now, it's kind of hard to tell. Like I can't tell. I don't even know like how big this glove's collision sphere is supposed to be. So without drawing that, it's pretty hard for me to say, like, okay, is there some kind of bug in the way that the sphere testing's happening? That means like really you should be able to place it in there, and like the collision routine is just saying no, even though that's not true. In which case that would be important. So I don't know. We've got draw sphere in here, and we don't really have any idea of how we would do that. But we should be able to produce at least something like, some kind of approximated, like we'll put some points, just, randomly put some of these things down there. We should be able to draw a few points and actually, outline the sphere roughly. So if we did something like, like a little like ring of points or something, or we do have line segments, so we could draw like a ring with a line segment. That just, you could imagine like an X ring, a Y ring, and a Z ring or something like that, which again is not going to be great, but, it would be fine. So, I don't know, something like... I don't know what we want to do here, but like, suppose we drew like basically octagons or something. And we just say like, okay, yeah, like whatever this is. We'll produce some angle here that's going to be the step index divided by the step count, right? And we need it to like return to where it came from, so we're probably going to want it to actually go like all the way up to step count, because we want to go from 0 to 2 pi so that the ring like closes. So we're going to have something like this, where we produce an angle, and because the sine and cosine routines are stupid, we're going to have to do this arbitrary garbage here. So we do like... like an X version, which is the cosine of the angle, and this is going to be like, I don't remember what our pi value is, at tau 32, something like that. So this is going to be like tau 32 times the angle, and this is going to be tau 32 times the angle, but with the sine. And so then we'd have like the points going around the circle, and we just need a radius value for these to make them into an actual point that we care about. And so what I want to do is just draw these line segments. You can see the line segment call here. Also, we should follow the convention and reset to sticky after we draw something. So here what we would need is we'd need a P0, right? And we'd need a P1. But other than that, it would be fine. Now, since we're drawing a sphere, we can just draw 3 of these at once, right? And what we could do is, what we could do is not do this, and just always compute one forward, right? So here what we would do is say that we've got an x0, y0, and an angle 0, and then we'd just do that again. I want to say that we have an arm 2. Yeah, we do. So we could actually just do this, where we just say like, hey, can you produce the arm for this? And that gives us the x and the y that we wanted, which that way it's just less code to type. Oops, because I didn't hit the copy button. And furthermore, I guess we don't need this angle anymore then, right? So we could just say like, okay, produce it directly like that. And then we have like an arm 1, or an arm, the 0 arm point and the 1 arm point. And of course, it's a little confusing because this is arm 2, which just means it's an arm V2, but nomenclature is never perfect. And so all we're going to do here is say like, look, give us the 2 points, the next one and the one we're on, and we're going to connect them. And if we look at what we do here, we can just draw all 3 rings with the same values, because the x and y for the sine and cosine are the same no matter which ring we're drawing. It doesn't matter. You know what I'm saying? Yes, there is plenty of noise. You can thank OBS's crappy everything for that. Anyway, if we go ahead and now produce the points for the different rings, we know that we've got radial values that have been stuffed. So like if you look at the sphere code when we push it, you can see that like P0 and P1 are the two values. So we have like a center value, and that's the entry P0, and we have a radius value, and that's the entry P1. So we have like the two pieces of information that we need to produce the sphere. And so when we push this on, we can produce the values for all the different rings by looking at these values. And I guess the sphere, technically this radius, I guess we don't ever allow it to be specified as ellipsoidal, so you can't actually specify different ones. Like, it's not actually letting you do that here, but we can support that here really easily. There's no reason probably not to, so I'm just going to go ahead and do that even though nobody asked us to. But what we would like to do here is just say, okay, when we do a push line segment and we do these P0, P1s, these are all just going to be the center plus the radius times the arm, right? They're all going to look like this. And so the only difference between which one we're drawing is what part of the radius value we actually multiply out. So in other words, if you imagine this arm 0, it's got an x and a y that are going around, right? And if we imagine a vec3 in here, where we just say, look, there's a radius x value times an arm x value, there's a radius y value times an arm y value, and then there's just nothing for z, right? That's going to draw one ring of the sphere. It's the ring that is in the, like, the plane of the world, if you will, so no height. And if we just permute which values we're using for that purpose, right? So if I'm just going to align this a little bit to the extent that 4Coder will let me. And so you can see what I'm talking about. In each case, right, we're just going to draw exactly this thing. And we're just going to permute which one of those values we fill in. And of course, you may be wondering, like, how do I know whether it's arm X or arm Y to multiply here? And the answer is it doesn't matter at all, right? Because in this particular circumstance, we're just drawing a ring anyway. So if you drew the ring by using sine, cosine, or cosine, sine, it wouldn't actually matter, right? So I don't think we actually even care about that, and we especially don't care about it because in this case, our spheres always have the same radius value. So it actually double doesn't matter because they're all going to be the same value anyway. So the only thing that actually matters here is that we do the permutation, right? So we just need to do this permutation, right? But if we did want to keep our winding proper, then we would know that, like, okay, XY winding, X cross Y is Z, so we know that this is going to go the right direction. If we're in a plane where Y is the normal to the plane, so we're doing XZ, right? If you imagine a right-handed coordinate system where you have X, excuse me, X, Y, and Z right-handed, right? So you have X cross Y is Z. So you imagine like the screen having X and Y and Z would be coming out at you. If you're doing X and Z, if you cross X and Z, it would actually be like negative Y, right? It would actually be going the other way around. So you can, if you want to, you could choose to like flip these, right? I mean, I don't know to what extent you would care, but you know, if you were actually trying to draw rings, you could imagine drawing these you could imagine trying to get these correct if you wanted to. I just don't know that it matters at all. In this particular case, because who cares which way around you're drawing it, right? I guess is what I'm trying to say. But you could negate them. So, for example, in this case, if you wanted to, you could have said, all right, we're going to draw it the other way around. We want it to go, you negate one of those. And you could choose which way you were negating it. So, but I don't know. I'm just not motivated to do that because it does not matter which direction around. We don't have to just go counterclockwise for any particular reason. I don't think it would matter. Excuse me. So running this now, you can see there's our spheres getting drawn. That's every time it does a collision detection on the sphere. You can see it actually doing the check, right? And now you can also start to see why what I was saying originally. If you remember, we made this thing, right? Where we wanted to turn on the ability to single step through diagrams. You can see why, because once you start actually drawing this stuff, there's too much information getting splatted for you to actually see. When we were only drawing just these squares, they are there's a few enough pieces of information that we could just see what it did, and we didn't really have to look. But once you start looking at individual collision checks, you can see that we draw too many things to actually know, like, is that sphere going to be able to be placed on one of these corners? I don't know, because I can't even see the sphere being placed there, right? So that's why I think we're going to need to use, we're going to have to implement this single step piece of things. And the single step, right, will be what lets us see what's actually going on in those individual collision steps, right? And without that, I don't think we're going to be able to figure it out. That said, even just from that piece of information, I think it didn't look right. So that there is that. Let's stop and see the puss in the field real quick. Hello. Okay. So let me just show you the reason that I say that, because I don't think it wasn't reassuring what I saw there when we started. So what I saw when we did this, right, and I went and I paused it. Well, I didn't pause it. I took debug camera so I could kind of come in here and look. So if you take a look at what's going on here, right, what I would have expected to see at some point is I would have expected to see testing of the sphere on this corner. But it obviously didn't do that, because if you had placed the sphere on this corner, you would have the sphere would come out way further than that. So I'm not really sure why I'm not seeing spheres further this way. Something's up, right? Because, unless I'm misunderstanding or, I don't get when we draw spheres, maybe, or something like that, then my understanding of how this routine was supposed to be working when I wrote it, which admittedly I never remember because I do this once a week at most, but trying to recall what we were doing with this routine, is each time through this voxel step, this piece of code right here, which is checking the corners of the voxel, this collides at P, right, should be taking the entity and the test point. And the test point is supposed to be the corners of the voxel that we drew, right? So I guess the problem is we never take the step. So we only test the ones in the interior voxel. When we go to update best, how does update best determine it? So, okay. So the problem is it's actually just failing the get closest point in box conservative. right? It's failing that check, so it never actually tests the corners of that voxel, right? So I think I'm seeing more clearly now what actually happens in this routine, and that's good. So here's like the breakdown. So the problem is, and you know, this makes sense, right? It's sort of what I said before, but it's a little bit different now. Or it's a little bit clearer. So when we look, we see these squares, right? So this yellow square here and this yellow square here, the two furthest yellow squares that we've got, those are actually never collision tested, ever. What's actually going on there is we're checking them to see if anywhere in that square would be a better location to place the entity than it already is. And they fail that check. Why do they fail that check? They fail that check because we are trying to move straight ahead in Y, and they are just X lateral motions. So no matter how far you move it in X, you will never get closer. You'll only get further away. So it doesn't bother to check those, right? Currently. Similarly, if we look at what happens here, we're going to go and say, all right, this square up in the corner here. Oh, and by the way, that yellow, so that is confusing. Okay. So I think there was something that I wasn't internalizing about how this works. I was sort of taking a mental shortcut, but that actually does... Okay. So there actually is a problem that we were not discussing before. And here's what it is. Red doesn't mean you can't place the player there. Red means you can't move directly through the current voxel to that voxel. So the actual problem with this voxel is not that you couldn't place the player there. And that, I think, is where the disconnect's coming from. You probably can, player, entity, you probably can't place the entity into that cell only because the rule is you had to have been able to move through the corner to get there, because that's the only way to get there from where we start. What that means is that even though you easily could have moved into this voxel and then into this voxel and then placed the player there, we will never try that, because since this voxel is marked as red due to this corner being colliding, we'd never know that you could have placed the entity in here just fine. So the visualization is telling us which squares we were allowed to move to. And really, that's more the problem. We never tested putting the player in here. And that's the important part, right? So... I'm not sure what that means for our future. But I do think it means we have to revisit the way this works. So, how much time have I got? Because I'm not sure what I want to do there. So I know exactly what the problem is now. I guess in this case, I think we should probably do more of a flood fill search. So, like on the witness collision detector, I did more of a flood fill search. Basically, you create a grid and then you walk through that grid, remembering which ones you checked and which ones are connected. I think we should just do that. I think we're just gonna have to do that. So let's just do that. Because I like looking at that, it seems pretty clear to me that that's what you actually want. I don't know if I should start that now. Like I don't know how much time I've got. I started at 11:30, so I don't have much time left. So maybe we'll just call it there. So it's like next weekend. That's just what we're gonna do. We'll create a grid, and then we will literally just walk the grid using the rules, remembering which ones we go to. I think that's what we want. So we're just gonna do it. All right. So any questions? Because I'll take Q&A now, and then we'll move on. What are those? What's that little like ghost moves out from behind a triangle? Oh, I need to go update the schedule. It's the schedule thing that posts it, not me. And I think I just haven't updated the schedule recently. I can update the schedule for next weekend. Instead of switching between O2 and OD manually, why not a different hotkey to build, release, versus debug? Laziness is really the answer. Separately, I guess what I would say, the way I usually do projects now is more like they're done in, like if you look at a more recent GitHub of mine, like if you look at RefTerm or something, the way I normally do things now is I just build multiple things in the bat. So this is an example of how I do things mostly nowadays, right? So I just do a CL with the debug flags, and then I do a CL with the O2 flags, and I just build them both so that I always have both. That's actually what I do now. And I should probably do that for Handmade here. I just haven't gone in and updated its bat file to be fancier. And then I just put in two of them. So I just have this one be debug, and then I use the little plus in Remedy to just have it, and then I just do that, right? I just switch which one I'm doing. That's what I do nowadays, and it is better. On day 565, you said that the multi-threading code in Handmade Hero was crappy, and that you learned much more about it since then. But what exactly is bad in that code? So I wouldn't necessarily say that the multi-threading code in Handmade Hero is crappy or not crappy, because honestly, I just haven't looked at it very carefully since then. All I would say is I almost certainly would, whatever it is, I do most things differently multi-threading wise now than I did when I did the multi-threading code in Handmade Hero. So I couldn't say exactly what would be different, but it would probably be different, right? That's all I can say. Can you explain what a discriminated union is? Sure. A discriminated union is when you take a piece, like a block of memory, and you're going to use a fixed size effectively. Well, let me be more specific. A discriminated union can mean different things depending on what language you're talking about. The theoretical definition of a discriminated union is just you have something like any kind of entity, an object in an object-oriented programming language, or a struct in procedural or block of memory or whatever, or just a conceptual thing in theory, whatever it is. And what you're going to do is say that thing can actually have any one of a number of types, and the type is going to be indicated by a field stored in that type. So it's got like a tag on it, right? And so the example in the diagram system that we just did is a pretty straightforward example of this. It basically says, here is a thing, right? So you have this diagram entry. And you can see that the diagram entry could mean many different things. One of these entries can refer to a begin, an end, a color, a thickness, a text, entry, instruction to stick the thing, spheres, lines, boxes, points, or overlays. All of those things can be represented by this one structure. And the difference is whether or not we set the type to one of these things. So a discriminated union is basically a way of saying we are going to represent many things in one place, hence the union part. And we are going to discriminate, like the discrimination between which one they are, like the thing that tells you, the indicator. An indicated union might be a better term for it because it's less about discriminating between two things as it is a flag, a signal that tells you which one it is. So maybe you could call it an indicated union. The indicator is a field inside the type itself that says it's this thing. Right? Yeah, and tagged union is a good name for it too, right? Now, there's like a bunch of stuff, like if you go read like category theory, which I wouldn't recommend, but some people like that kind of thing. It's a theoretical thing as well. So like there's theoretical discriminated union, and in the theory realm, what they would be doing with it, like we're solving a very practical problem with it, right? Like we just want to have this uniform piece of code that deals with all these different entries, and then only once in a while do we want to actually discriminate, right, between the unions, and we use the type field for that. But a lot of the time we want to handle them as all being the same. And that's what a discriminated union is for in practical purposes. It's being able to deal with everything as being the same, and then only once in a while do you actually differentiate between them. In category theory, they're going to be more interested in things like proving that a particular thing will be true or not true, based on if the type of the thing is a discriminated union, like what does that mean in terms of being able to like analyze the correctness of this piece of code or this idea or algorithm or whatever. For someone just starting filling Handmade here, would you recommend against using direct sound? I guess what I would say is if that's the kind of thing that you're worried about, you're probably worried about the wrong things. It doesn't matter what sound API you use. You should look at sound APIs as just something you can change out whenever you want. So like you should never care what sound API you use. Use whatever sound API you want. Make sure it's isolated in the code like it is in Handmade Hero. And then if for some reason you have a problem with it at some point, you can swap it out for something else. But you should never really worry. Like, thinking about things like what graphics API or sound API or whatever to use, usually if you're thinking too much about that, that's probably just a bad sign. It doesn't matter. The code you write should not care about that because I guarantee you it will change all the time. Right? And that's kind of the problem. It changes all the time. Like whatever stupid sound API Microsoft craps out tomorrow is the one they're going to tell you to use. You can't actually base your decisions on that. Just assume that there'll be some new stupid crap API that you'll have to use on some platform for some reason. So the important thing to think about with audio is just make sure all of your audio code doesn't care what API is using, and that you minimize the amount of code you actually write that relies on it. And that's what we did in Handmade Hero. Like in Handmade Hero, before we shipped this thing, If direct sound sucks too bad, we just rip out that, I mean, what is it, like 300 lines of code, 200 lines of code? It's almost nothing. We just rip that out, replace it with a different API, and that's what you want, right? So that's the most important thing to think about when you're thinking about sound APIs, is don't think about sound APIs. Assume they will change, and definitely don't care. Does the order in which entities move change the result of your collision detection? Yes. So this is not a simultaneous move collision detector. There's different ways that you can do collision detection. And some of them are try to do simultaneous move. And what that means is that you try to move entities at the same time to see if they would overlap during the movement, right? We're not doing that, and we don't have any really need for that. If you're doing like things with physics that are, you may have issues with that, right? But I think we'll probably try to avoid needing that. Do you think the concept of IAM-GUI is applicable the same way in 3D user interfaces? Yeah, so just to be clear about IAM-GUI, when I invented that, that was the actual reason. Believe it or not. The reason for that I originally did IAM-GUI was because I noticed... I mean, it's usually the reason. I was working on the editor, the viewer for Granny back in the old days, was the character animation viewer. And I wanted a way to unify all of the ways in which you interacted with stuff in that thing. So actually, that is what IAM-GUI is actually most designed for, is the ability to not care what kind of thing you are interacting with, right? You invented IAM-GUI? Yes, I invented IAM-GUI. I am the person who... I literally am the person who made the term IAM-GUI. Nobody had ever said that until I said it in an email in like 2001 or something. I don't even remember when it was. Mike Acton recommends sometimes doing deliberate practice for programming as opposed to working on projects. Have you done this yourself, and do you recommend it? I guess I would say I don't think that I would necessarily agree with the phrasing. I think, like, in terms of, like, conceptually, I agree and would give the same advice as Mike Acton gives. But I wouldn't necessarily give it the same way that he gives it, because I think it puts a little bit too much of a delineation between what is practice and what is not. To me, the way I would phrase it is, you should often take time to try something new, right? That to me is the important part, right? So one way of doing that is to actually to demand that you are literally going to go off to a fresh code base with nothing in it and do some practice at something, right? And I think that's what Mike Acton is saying. Like, go literally do fresh practice. The amount of times that I literally do that are actually very few. The more important thing to me is that you always try new things when you think of them, or you forced yourself to, like, say, how could I do this differently, and try it. That's the important part of it. And a structured practice session is a way to force yourself to do that if you don't normally do that in your own code bases all the time. But I normally do that all the time, right? So I think it depends on what kind of programmer you are, right? Wait, Wikipedia credits me for that? That's like the first time Wikipedia has ever been accurate about something. Wow. All right. I didn't know that that was the case. But hey, thanks Wikipedia for the credit. I appreciate it. Were there IMGUI interfaces before you coined the term, or was the idea and term completely original? So I had never seen anything that did that at the time. But I don't know. I think it would be very hard to determine if anyone had ever done it. My suspicion would be that people had either intentionally or accidentally done something similar in the past and had never thought to actually like I would have to imagine that at some point somebody accidentally did it. Because it's pretty easy to accidentally do, right? So I'm guessing that I'm guessing that someone probably did and we just don't know. No, I wouldn't coin a different term. I think immediate mode GUI is exactly the right term. Did you also coin GJK? No. GJK is the initials of the people who invented it. How could I have coined GJK? It would be like MGJK if I had invented it, right? It would have a Muratori in there. GJK is literally named after the people. You don't have to wonder. It is literally named at... What? There we go. It's literally the initials of the people who invented it. Yes, I definitely... Did you coin JavaScript? Yeah, I mean, definitely. Yeah. Yeah, I don't have a Wikipedia page, but I mean, I think that probably makes sense because in order to have a Wikipedia page, you have to have public materials that can be referenced, like that are historically about you, probably. Like if you want to have a Wikipedia page, you have to give like interviews and stuff, right? So because they have to be able to cite things like Wikipedia can't just be like, let me go like to this guy's blog and like copy the crap in, right? Like they have to be like third party sources where it's like, oh, with this interview with Casey or whatever he said, blah. So I think you need to you have to be more of a public persona than I am. Like you have to go out and like create news about yourself if you want a Wikipedia page. And I don't think it's Wikipedia's responsibility to change their rules. You know what I mean? Someone may have made a Wikipedia page for me at some point, but it would get removed because it'd be like there's no references here. right? And so I think like that's really more important, right? So you want to do like interviews with journalists, whatever that means these days, and you know put more like third party write ups about you is what you're looking for there, because I would imagine that you could do Wikipedia searches for people who are like extremely important. Let me just see here. And like it's probably pretty tough, right? So like, you know, I mean, I guess this managed to have a Wikipedia page, but like it's pretty brief, right? And it's got some citations to actual like news articles, right? Um so, you know, I don't know. I don't know how many people actually have these pages. So in terms of, so I don't know. All right, that one's kind of like maybe questionable, right? Not much citation there. So I don't know. I have no idea. Maybe there should be a Wikipedia page. But my point is just that, like, in general, it's pretty hard to make a Wikipedia page for somebody who doesn't do a lot of interviews with stuff, right? Because Wikipedia is an encyclopedia. It's not like a news source, so it can't just like take your live streams or your YouTube videos or your whatever and say like, well, here's what it says on those. Because like one of the Wikipedia things they try to do is not have self-described stuff on the page. So if the thing is coming just from you, they tend not to use those. Like that's considered like poor referencing for a Wikipedia page. For better or for worse. I mean, you could argue that nowadays that doesn't make any sense because most of the things produced nowadays for informational purposes are produced by the person. That's a major change in how information gets produced thanks to the internet, and that's a good one. So you could argue that Wikipedia's methodology is actually bad because why would we want third-party sources for something when we literally have like a complete record, right, of what happened from the actual people who were actually posting, and you can literally see it all, and you can just say, well, here's what they said because they said it right there, right? So one could argue that Wikipedia is kind of at this point anachronistic, and maybe Wikipedia is probably just not that relevant anymore. That could be. But that's the way it is. So when you're wondering why there isn't a Wikipedia page about something, oftentimes that can be a very valid reason. They're just following their own rules, which, you know, they made, and, you know, that's what the page is. Microsoft is setting fairly strict hardware requirements for Windows 11. Basically, chips older than 2 years will not work. Do you think that is a good thing or a bad thing? Seems like it will lead to a lot of waste of perfectly good hardware. I don't know. So let me say a couple things about that. I don't have a strong opinion about it. I guess what I would say is I would have to see what the requirements are, which I haven't looked at, and what they actually are designed to do. Right. So hardware requirements of the form, we need a machine to be at least this powerful because otherwise it can't run Windows 11, are garbage. Because Windows 11 is garbage, as was Windows 10, as was Windows 8, as was probably Windows 7, and definitely Windows Vista. So obviously every single version of Windows, including the latest one, in terms of actually hardware power-wise, it's all garbage. You could run the thing on a freaking, you know, Pentium, right? If you actually wrote it well. So that's true. But the Windows kernel team has to make a kernel, right? And there are a lot of changes, structural changes to processors that happen over that time period. Right? And so if the requirements are there because the Windows kernel team was like, look, if we want to be able to do like high performance stuff here that doesn't have a bunch of weird like side cases for preventing Spectre and Meltdown problems, and doesn't have a lot of weird side cases for like how do we deal with the fact that this thing only had one thread so it couldn't do multiple blah or whatever all that stuff is, right? If the requirements come more from the Windows kernel team about features that are on a chip, that I would be more okay with, right? Trusted platform modular requirements are ridiculous. Any trusted platform module is just another way of saying I would like this machine to be hacked. Trusted platform modules should never have happened, ever. They are a absolutely ridiculously stupid idea. I said that at the time. Trusted platform modules are absolutely ridiculous. I don't even think trusted platform modules should exist. The only use case I can ever see for trusted platform modules is for unscrupulous large corporations, which is exactly what Microsoft is, using them to prevent you from doing things with a computer that they don't want you to do. I cannot think of a single other use for a trusted platform module. Like I literally have no idea what any other thing that a trusted platform module would do. I have no I can't think of a single other use case. You certainly can't use it to store important data because people already know how to hack trusted platform modules, right? And more importantly, the trusted platform module is the last place you would ever store important information because any hacker immediately knows to target the trusted platform module, right? Or like a state actor, right? When the NSA or whoever else, China or blah, 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 whenever they're manufacturing this stuff, of course they're going to put in something that lets you hack the trusted platform module. It's obvious, right? So any important target can't trust their trusted platform module. It would be a stupid idea to trust it. It's basically a big red bullseye that says, hey, compromise this unit. It's ridiculous. Of course no one would ever trust a trusted platform module. They had any idea what they're doing, right? The only trusted platform module you could trust is one you literally made yourself. Have I ever used a physics engine like Havoc Physics or Bullets? No, I haven't. Same opinion for trusted modules. Yeah, my opinion on trust modules is that they don't actually provide any. I don't know what they supposedly provide, right? I literally don't know. Because what makes you think that you can trust the trusted platform module? I don't know what. There's nothing inherently trustworthy about a trusted platform module. It's just another piece of hardware that someone gave you that they claim you can store something on. But why would you believe them, right? They can have bugs in it that allow it to be bypassed. They can have intentional backdoors that they placed there so that they can, or that someone else placed there so that they can get information out of it. It doesn't make any sense. All you're doing when you use a trusted platform module is guaranteeing that the hacker knows where to get the stuff that you don't want them to get. That's the only thing that a trusted platform module does in terms of security that I can think about, right? All right, I think it's about time to wrap it up. Hey, do we have any... Here's a question. Sometimes we got people... I don't know. Probably not. What time is it? So if I go to Google and say... No. All right, so we probably don't. I was wondering if we had any Iranians watching. Sometimes we get people watching from places around that region. I don't know that I've ever actually had someone... Oh, you know what? I think I might have had someone write in who was from Iran. Does Twitch work in Iran? Well, I mean, a lot of people use stuff to bypass, like, you know... It probably... I don't know if Twitch works in China either, but people will do bypassing, right? Like... so I don't know. But I was gonna say, like, tonight I was gonna go get some grilled meats at a place that does like really good Persian style, right? Grilled meats. And I was wondering if anyone who might be like more knowledgeable about like yes, Navid HG. Exactly. That is exactly what I'm talking about. I was wondering if anyone had any opinions. It's one of my favorite dishes. Like, I don't know, I guess, like, I guess technically, like, my ancestry would come from the Mediterranean, because they're all Italian, and I believe they were sort of more southern Italian. And I do tend to like Mediterranean dishes. Like, everything from the Mediterranean, anywhere around, I tend to like. And I pretty much like all Mediterranean grilled meats. And they're somewhat difficult to get, right? In this area. But there's 2 or 3 places that actually do it, right? And so, you know, like, I was just wondering, you know, I've started to try and cook them. Like, I do yogurt marinated chicken myself now. And I'm sort of getting... I bought a thing of saffron from the Costco. Costco actually has like really high quality saffron that's not too expensive. Saffron is fantastically expensive. If you buy it in the grocery store, it's way too expensive. Way too expensive. But you know, you can... Costco, like everything Costco does, they manage to get you high quality stuff without having to mortgage your house to get it. So I definitely appreciate the Costco for hooking us up with that. So like I've been working on that stuff. Yeah, Boop is the handle he had on Discord. It's Ashkan Kiani is his actual name. But yeah, so I was gonna go out and get some, and I just curious if people had like pro tips on seasoning and stuff. I'd like to be able to make it more. I'm getting better at the chicken. My main problem with doing the with doing the grilled chicken though, I think I've got the yogurt marinade down. I think I've got the spicing pretty good, right? Like I've got like I do like the lemon saffron butter basting and all that stuff, and it comes out really great. The main problem I have with doing the chicken, and what's the name of the chicken? It's like Juja, or it's got a name. The grilled skewered chicken with butter based. You know what I'm talking about? Juja, yeah, Juja. So the Juja kebab, the main problem that I have with it is I cannot figure out how to get the doneness correct. Like when you put it on a skewer, you can't really, it's really hard to like temperature probe. So you kind of have to go by like some kind of like intuition or something. And that part is tough. I don't know how you do it. Virtual one. So when you say touch, like, can you be more specific? Is that really true? Do you know how to make these? This show, I would like to know how to know the doneness correctly. If you want to get good Middle East, Levant type of seasonings and other produce in Seattle, try Goody's Mediterranean Market. All right, I will write that down. I've never heard of that. I'm going to make sure that's up here. Store location. In Lake City Way. Okay. Is that the one you're talking about? In Lake City Way? Yeah. Wow, house-made kebabs ready to cook. That's great. Cool. Yeah, all right. So I hadn't thought of touch. Maybe I'll try that. One thing that I messed up last time that I realized after the fact was that so you marinate it, you put it in like when you marinate the chicken in yogurt, you put it in like a bag, right? Or something. You have to put it in something. And when I was letting it come up to room temperature, I actually let it come to room temperature and then I put it on the skewers, and I realized that was really stupid because I think like some of the chicken that was on the outside thawed more completely than some of the chicken that was on the inside. So then when I flame, when I grilled them, some of the chicken I think didn't cook and others did. So that was a big problem. And so I can fix that one. But I still, even after I fix that, which I think you have to skewer them right from right from refrigerator, or you have to skewer them probably and then let them sit skewered so they actually do it correctly. Yeah, I rotate the skewers manually. I do it just like I saw like YouTube videos of actual, like, at least what appeared to be fairly hardcore Persian meat folks doing their own grill over the coals. And I try to do it like they do. So I hand rotate the skewers continuously, and I swap their positions too to make sure that in case one part of the grill's a little heavier or whatever. Right. So I do it, and I've managed to get that pretty good, but I think I've got some other problems. However, I think I could fix most problems. The only one I wasn't sure is like, how do you know when the chicken's done? By touch does sound like a pretty good idea. Push on it a little bit, see what the springiness is. That's not a bad idea. I wonder if that would work. That's a good idea. I'm sorry to bring up all this good food, and I realize this isn't even a cooking channel. Yeah, I'm hungry too, so sorry about that. An infrared thermometer might not be a bad idea, Sir Pinecone. I kind of agree with that. That's interesting. Yeah, you're right. I guess I don't know that they always take the entire skewer off at once. They might just take off some of it. Yeah. But again, even if you did that, so if you know that you're going to take it off the skewer separately, that makes it even more important to have a way of testing if it's done, because then now you're saying I need to, you need to be able to test it and say, okay, this part's done, let's take it off the skewer, right? So that again is like a problem, because like I don't really know how to do that test. So I guess what I need to do is learn the touch, right? Like learn what that touch is, and then I could do it. That I never thought about that. But yeah, like by touch, or yeah, maybe learn what the infrared outside temperature would be when the inside's done, just by testing, and then remember that, and then just go by that. That seems reasonable too. I like that. Yeah. 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 All right. That's a good suggestion. Thanks, folks. All right, I'm going to go ahead and wrap it up here. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code, so you can play around with it. I will be back here next weekend. I'm going to try and update the schedule. Sorry, I've been forgetting to update the schedule lately, so it's just been kind of not up there. So I realize it's harder, but I will try to update the schedule so that it should put the reminders up again for those of you who need them. Until next week, have fun programming, everyone, and I'll see you all on the internet. Take it easy, everybody.